0.9 recurring is equal to 1. I first learned about this in a high school advanced functions class, however to this day I still find myself equally amazed by this fact. Let's look at a simple number line. Two real numbers are considered distinct if there exists another number in between these two elements, having a sort of gap between them. For example, we know 11 is not equal to 12 because 11.5 slots in perfectly between them. As such, if 0.9 recurring and 1 are distinct, there must exist another number between them. Now with this in mind, let's look at probably the simplest, and thus my favorite mathematical proof for this. Let x be equal to 0.9 recurring. Multiplying by 10, 10x will be equal to 9.9 recurring. Splitting off the decimal portion from the integer portion, this allows us to substitute 0.9 recurring with our variable x. Rearranging such that there's a single x in our equation, we end up with 9x is equal to 9, or x is equal to 1. Keep in mind the first statement we made, that x is equal to 0.9 recurring. If x is equal to both 0.9 recurring and 1, this implies that 0.9 recurring must be equal to 1. We can also see this pretty easily with the fraction 1 over 3. When 1 over 3 is multiplied by 3, we get 1. But remember, 1 over 3 can also be represented by 0.3 recurring, being equivalent to one another. Multiplying 0.3 recurring by 3, we get 0.9 recurring. If both these statements are true, this also implies that 0.9 recurring must equal 1. Now that we've gained a better understanding of this fact, let's delve into why it may not be so intuitive. A common misconception with 0.9 recurring being equal to 1 is that people have difficulty grasping infinity. Despite the fact that the 9s in 0.9 go on infinitely, people still envision that there is an end to this number eventually. Another is the fact that numbers can be represented in different ways. No one really seems to bat an eye when we say that the fraction 1 over 3 is equivalent to 0.3 recurring. However, when it comes to integer values, the idea that it can be represented by a decimal can be jarring to many. What I really love about this problem is that it is a fantastic introduction to the concept of infinity, helping simplify maths such as limits and infinite series. But my favorite thing is how counterintuitive representing an integer as an infinite decimal may seem, showing how math really isn't as objective as you may think.